Hey guys, welcome back to another video, and I'm Tarish. Welcome back to TNT Academy. And in today's video, we're going to be talking about kinematics. We're going to be talking about velocity and speed and velocity. Now, see, why am I addressing this so early on, and why you guys must be wondering, hey, we're in 11th. We already know what these two terms mean, but just in case. So, speed means there are two types that we're going to be talking about. We're going to be talking about average speed and average velocity. And we also have to talk about instantaneous speed and instantaneous velocity. Okay, I don't know why I wrote that in normal, but anyway, so we have instant speed and instant velocity. So now let's talk about these two. What do these mean? So average speed and average velocity. First of all, the difference between speed and velocity is in speed we talk about distance, and in velocity we talk about displacement. We talk about displacement here and we talk about distance here. Now, what do you think is the difference between these two terms, distance and displacement? Well, if let's talk about vectors for a second. I know we just spoke about vectors, so it's also going to make my life easier. So it basically means if I have a vector like this and I have another vector like this, I have a vector A bar and I have a vector B bar. Now their total distance would be this plus this. But when we talk about displacement, it's a different story. Sorry about that. Displacement just means the fastest possible way to reach your final point. Now we all know this is our final point, correct? So now how do we reach this final point? Well, isn't this the fastest way? This is the fastest way, correct? Now if this is the fastest way, why do we have to even talk about these two? So that's why we have something called velocity. We have something called velocity and we also have something called speed. We have something called velocity and we have something called speed as well. So the thing is, now that we have defined what displacement, distance, speed, and velocity are, we can now get into the finer details. So the first thing is average velocity and average speed. So I'm just gonna write speed here, and I'm gonna write velocity here. Velocity here. Now the first thing is average. So average speed just means the total distance over the total time interval. Now here on the other hand, it would just mean it's also represented as delta S here and delta V here. This would be total displacement, and we have an issue here, so I'll just write this as displacement for now. Displacement by total time again. Now you might be wondering also, why do we have this instantaneous and average? Now average just means the total distance over total time, total velocity over time. As in, if I have my let's say my marker here, and my marker is moving a total length like this, we know our total distance as this, and we also know it was traveling in some time t, or it was traveling in 2 seconds. But now if we talk about how, if let's say our marker suddenly went forward like this, then it stopped for 2 seconds, then it again went forward, then it came back again. So you can see something is going on. What is different? The thing is, at every single different time, there is different acceleration. For example, when I start, my velocity or my marker here is going forward with some acceleration A. Correct? That is simple. It's going forward with some acceleration A in the beginning. Then all of a sudden it stops. What happens then? My velocity becomes 0 and my acceleration, which is just accelerating the body, has become deceleration, which becomes 0. Then all of a sudden it again accelerates. Then it again comes back. So here there are different accelerations and there are different velocities. But if we were to talk about the total, we would talk about it just traveling from point A to point B in some period of time and this distance. So we wouldn't even care about the different velocities of speed. So where do we inculcate, or where do we find these different velocities? Where do we find? Because this velocity of suddenly going forward and stopping is equally as important as maybe the next velocity, because all of these velocities are different because there is different acceleration. So that's where I think you guys have gotten the idea, where instantaneous velocity comes into the picture. I'm sorry, I don't think you guys can see this as well. So instantaneous velocity, if you were to define it as, it would have a bit of differentiation, and I hope you guys already know what differentiation is, because differentiation and integration, basically the calculus, is a core fundamental in kinematics. Because in instantaneous velocity, now when we talk about differentiation or we talk about acceleration or integration, right, you know what we are talking about. We are talking about minute small things happening. For example, sorry about that. So our instantaneous velocity in the first place is talking about the exact velocity at a particular time, at a particular very small time. The velocity, the change in displacement in some very small time. Now you tell me, if it was some very small time, like let's say just you see this has happened, right? Now this is a whole motion, but what I want is when this marker just went slightly forward. Let's say if this was some motion, all I want to know is the velocity at this time. Let's say this was some motion, it stops here, it waits here, then it starts again with some higher acceleration, then it waits here, then it has some deceleration, it starts coming back, then it comes back to the original point. So I want to find my velocity here, here, here. These are all instantaneous velocities because these are all adding up, as in not adding up, but these are exact velocities at some certain time interval, So let's talk about this again. So if we were to define it, we would have to define it as velocity would be equal to d by dt of x. I'm going to write this as x, and x is the and I can write dx as the change in position. Now why do I write dx as the change in position? Because dx is literally what that means. Dx is what it means, change in position. Dt can be known as change in time. Now again, I have to remind you that this is in some very minute interval. This is in a very minute interval. This is taking place in a very small interval. This d by dx by dt, it's happening in a very small interval. So we know what, and if this is what velocity means, then speed, the difference is its change in distance. Now it's the exact same thing, but you'll understand shortly that velocity is a lot more important. So we know that the small change, we already know that x by t is equal to velocity anyways, right? X by t is equal to velocity. So all I'm saying now is I'm taking a very minute x, taking a very minute t. So you can see we are differentiating this. So when we differentiate our x, when we differentiate our x with respect to t, we will get velocity. When we differentiate, similarly, when we differentiate my velocity, dv by dt, we will get acceleration. So that means if I were to substitute v's value from here, I would get d by dt whole square, or I could say d square x by dt square, right? Because I'm substituting this value again as v. So I will also get this is equal to a. Now this is very important because in future problems we will understand how we implement this. So now I hope you guys understood what instantaneous velocity really meant and what change in position or change in time also meant, because in our next lecture we will be talking about this slightly more in depth, and we will also be talking about problems where this is all used. And now again, we will be using these two and also sometimes average velocity. And I have to remind you guys, the formulas that you saw in the beginning of the lecture, s is equal to ut plus half at square, v square minus u square is equal to 2as, and v is equal to u plus at. Now these three formulas are only used when our acceleration is constant. Now here our acceleration does not need to be constant. This is why instantaneous velocity came in the first place, right? Because if it was just constant, we could just take total time by total displacement and call it a day, because our velocity is either just increasing at the same amount, so it doesn't really matter to take instantaneous because it's the same everywhere. But when we talk about instantaneous velocity, it could be some x in one spot, it can be y in another spot, and the velocity and acceleration are always changing. There's no relation between all of them. So, anyways, I hope you guys enjoyed watching this video, and make sure to watch the next video because this topic is really interesting. Thank you for watching this video.